where we may not compile the first time, but we will try again until our code works and does what we're expecting it to do. So today we're going to look at another easy LeetCode problem and, fight our way through till the end. I believe we're going to be looking at a tree problem, so let's jump into it and get started. Alrighty, so here we go. Today, this problem looks like the problem invert a binary tree. So we're given the root of a binary tree root, invert the tree and return its root. And by invert, they're meaning like flip all the left and right nodes for each node. Okay. Yeah. And then like here's the array of values. Okay, so yeah, for full disclosure, I have never seen or done this problem before. And so, yeah, we're just gonna fight through it together. I'm doing this to show that, like, people don't start off as LeetCode experts or as experts in anything. You know, everyone's got to learn everything they know how to do at some point. So sometimes it's fun to see the YouTubers solve the problem, especially if you're trying to learn how to do it yourself. But then the next part is just getting out there and doing it yourself and getting used to talking through the problem and things like that. So okay, the number of nodes in the tree is going to be between 0 and 100, so we can have an empty tree. If, so this it takes in root, so if not root, return. What do they want us to return on the empty thing? Just an empty array? Great. All right. And then, excuse me, so let's see. We could do this a couple different ways. Yeah, or I guess if root equals just an empty array. Okay, the way I'm thinking of doing it is kind of like for each point, like return, like, where is, alright. Yeah, so for each node or branch, they'll only have two things, or leaf nodes. Sorry, my vocabulary is a little, yeah, nodes in the tree. Okay. Yeah, we're working on it. We're getting better together. I'm glad you're here for the ride. So yeah, for each node, we have the leaf nodes. And it's not like this is a sorted tree or anything like that. So it's kind of like, I'm thinking like, is it better? Well, first of all, okay, if we're doing, oops, jeez, hello? Sorry. Okay, if we're doing this as a problem, like, we know we'll have to take this value, put it as a temp, move this to here, and then you can put temp in there. If we have some situation where we have nodes like this without a node here, we could just move it like this, and vice versa. If we had a situation where we had like a node here and nothing here, we could just move it like this. Then I guess if there's the tree node with no nodes, we can pass. Like with no downstream values to deal with. Then the only thing is, do we want to have like a while loop? So that way we could like have a queue of visited nodes. And then, or we could do like a stack. Because stack is like a stack of plates where it's like first in, last out. Because if you think about a stack of plates in like some of those all-you-can-eat buffets or whatever have you, usually they have like guards on the side, so you can't pull out like the bottom plate. You have to pull a plate off the top, and you have to load the plates in through the top. But then if you have a queue, like a line at the bank, which is my go-to analogy, then the first thing that goes in is the first thing that comes out. So yeah, I mean, I'm thinking that like if we go through this, it doesn't really matter what or which implementation method we use necessarily. Once we hit all of these like lower cases and then work our way up to the case where there's like a lot more going on. So let's do that. So yeah, this is like if the tree has like no actual values. We'll let this finished array, or sometimes people call it like a visited array. Sometimes people need a queue of the things that we need to, excuse me, items that we need to interact with. So I'm just going to take a minute and think of which approach I think would be the easiest or best for us here. I think let's do the stack method. The stack method is kind of what I would make akin to the binary order or a level order traversal, but kind of reversed. So like we start at the leaf nodes, reverse anything that's there, and then we come back up and reverse things all the way up back to the top. So what we'll do in my example here is going to be that we're going to like loop through everything, put all the points into the stack, then in a separate loop or a secondary loop, unwind the items or flip them, invert them, and return them when we are done or when they are interacted with. So yeah, and then this is O of n time. Since we won't be doing nested for loops, we should hit that. O of n space, sounds like we should hit that since we're going to be putting that into an array, and then we'll have the new tree that will be returning at the end of the problem. Sorry, okay. So, so yeah, let's let this stack be this empty array. Oops, like this. Excuse me. And then what we could also do here is we could put this first, and then, so if root is just an empty array, then we return stack. Excuse me, and that takes care of our like base case there. And then let's get into our other stuff. So then the other thing is going to be like at the end of like the while loop when we're putting things back together, we're going to need to return that last thing. So I'm thinking of like how we're going to hold on to that, but that could be a comment on a problem for future us when we're older and wiser. So how will we return the last node of the tree? Excuse me, yeah, surely that'll invert the tree and return its root. It's funny because this is showing almost as if the root had all these values, but I'm guessing it's just going to be the first value right there. Unless it's showing like all the values in the tree. I guess then we could just return root, because if we're inverting it in place as well. Yeah, I suppose that's what maybe they were expecting. Yeah, so here, excuse me, return root. And then just a note to self, we are inverting a tree in place. And that is also why we are doing this like temporary holder value here when we are moving things. When we have another, so if we have an item in this position, we have to store it as a temporary value before we can move this item to this position, or else we would lose this item. Since we're doing it in place, that's why that's important. If we were like remapping this as a different, fully different stack, which I guess is probably an alternative solution to this. We would set the items as like nodes or whatnot, and like for every item, like this dot left equals right, this dot right's value, like the current value of whatever is the left node, and that might actually be a faster way to do this. I mean, not like faster in terms of like actual time or space complexity, maybe just like faster in terms of writing code, which hey, a win is a win, right? Like, yeah, so, and it's O of n space, so it's the same amount of space if we store a new tree as if we just did the whole stack thing. Yeah, let's go that way actually. So yeah, if root is this empty array, we'll return this. So instead of stack, let new tree equal this. Okay. Like, how will we? Well, I mean, we could pass tree.root into something. So I guess while, but I'm wondering like, here's where I always get tripped up with code stuff. If I were doing this for code on work, for example, I wouldn't want to change the input. Like I wouldn't want to delete stuff or lose points or something like that. So how is the best way to approach this? I think the best way to approach this is to still have a stack, loop through the first array, push all the values into the stack, and then go back through the stack and like swap the things. Yeah, I like that. I mean, I don't know about you, but I don't like to change the input stuff, you know, just in case someone else needs it or whatever. Like, I'm also a front end developer, so oftentimes like data is being passed to us to just display, but we're not trying to like adjust it, like the underlying data in any way. So yeah, habits die hard, I suppose. I'm still gonna go into the stack. That's gonna help us for a while loop. And then, so if you want to have a stack with while loop, that is like if it's not empty, while stack, then you have to set something inside of it. So we start off by like stack, by pushing the root into there. So like stack dot push root, or we do root dot value, but I'll do root so that we have all of the value left and the right because we need that truly. And then I like to put the semicolons in on the one line if statements for sure. So that way we know that like this is the only thing that's being returned in that case. Okay, so we're just about to really get started here, but I noticed that we don't have anyone in the room here yet. So what we're going to do is we're going to take a quick break. One of the things I really try to advocate for is like self-care and all that stuff. So when I'm working or studying or whatever, I try to hold myself accountable to taking like, or working in 50-minute increments and taking a 10-minute break. So yeah, let's take a quick break and then we'll be right back to get stuck in and hopefully finish this problem. Talk with you very soon. We'll try again until this code compiles the way we want it to. Later. Okay, welcome back to Try Again Dev, where we try again to solve some problems, get some code to compile, whatever we're doing that day. Today we are continuing to solve this problem where we want to invert a tree. So far we have decided we're going to make a new tree array of points and values. I now see, excuse me, why this one is showing like it as an array, because I guess they just save this stuff as array values, you know, sure. We have covered the edge case where there could be like no items or values in the tree that were given. We've created a stack for ourselves and put the root into it. And now we get into the meat and potatoes of putting all the points into the stack, setting the left-right situations for each item. So let's do it. And also I'm just gonna call this one original stack. Yeah. Or even original tree stack, sure. Just so we like totally know what we're talking about when we're referencing these variables. Okay, it looks like my levels are good. We are still streaming. Let's make sure we have gotten no interactions that we've missed, and like we're ready to rock and roll. All right. So now, while we have items in the original tree stack, so first in, last out. First in, 1, 2, 3. Or level order traversal. Let's just think about how we're gonna put these things in. So this is one left, and this is one right. Yeah. So we'll do node, or yeah, well, let's see how we're doing this tree node. So we have this dot value, this dot left, this dot right. Okay, so we're gonna go through the stack. We start off by putting the first item into the stack. That's what we've done here. If we are taking this item, are we taking this item from the stack, or are we just going through the node? I think we're just going through the nodes. Okay, well, we can do both. I'm just thinking aloud to myself here. Because like as we go from 1 to 2 to 3, we have 1. So we can put these two items in the stack as in they need to be addressed, but we could also, as we're here on node 1, reverse the stuff or their left and right values. I think that's a decent idea. So tree processing stack. So now I know what we're doing, and let's start doing it. So what we did is we put in the first node of the tree, which in this case is 1. So while we have this 1, what are we going to do? Well, we're going to say we're going to take the first thing off the top, which means, or like if it's level order, maybe we should just do it as a queue. It's funny because so far I'm just renaming this variable. But it's for the very important use of organizing the thoughts. Because I'm like, yeah, we were saying like we'll start with this, like 1 and then 2, 3, so that's node dot left, node dot right. And then I'm wondering if we'd want to have some sort of marker. But I don't think it matters. Because then we'd put these items in as well. System, so it should be fine. So anyway, let's just write the code, and if there's other things to come back to, we can write notes and come back to them. So yeah, I'm not sure we're really using this new tree, but that's okay. Let's maybe do it in place or see what happens with our code here. So we have our tree processing queue, we put in the first item. What do we want to do with this first item? Well, we want to take the first item from the queue out from the front, so we're going to shift everything forward. So let current node equals tree processing queue. Oh, okay, not VS Code. That's fine. Okay. Tree processing node dot shift, aka take the first value. I think of shift as you have to shift all the things forward when you take the first value out, or you have to like unshift, aka squeeze all the values backwards when you're putting something in at the beginning. So we have our current node that we're processing. We're going to put the next nodes into the queue and process this node, and then we're going to go from there. And I'm just going to put a note to self if left or right values are null, skip. So that way we're not like going into any null territories, which would break our loop. Oops, excuse me. Okay, so let's do it. So we have our current node because we took it out of this thing. So now we have to look at our cases here. So Also, to see if continue helps break a while loop. Does continue while loop. Yeah, increment is the word. Okay. Yeah, I want to see that in JavaScript. Yeah, I think it's the same thing. Awesome. Just wanted to make sure. Okay, so if current node, if node dot val is null for some reason, continue. Yeah, that was this case here. If the node has no children, if one of the nodes is empty, or the children nodes, if node dot left is null, node dot right is node dot left. And actually, I think instead of this being node dot val, it was like both of them were null, like node dot left and node dot right were null. Then we just skip like this case pretty much. Because we're looking at like if a node has children before letting it pass on to the next value. So anyway, one of the things that we'll need to do is put in the left and right values into the tree processing queue. So let's make sure to do that before we forget. So tree processing queue dot push node or current node dot left. We're gonna do this again with tree processing queue dot push current node dot right. Okay, and then we're gonna make sure that here we have references to our proper value here. So, okay, so now we make sure that for each point, we put in the next item. I actually want to put these in if statements because I don't want to put them in if they don't exist. So let's code that up real quick. So if current node, so dot, and then we'll come back to that, and then like, what is the best way forward here? Okay, let's come back to the beginning of these lines and add the spacing we need to close those statements, and then we can auto format. Awesome. So yeah, if there's a current node dot left, we'll push it into this thing, and if there's a current node dot right, and it is not equal to null, because we don't want null values going into our lovely array of places we're going to visit, or else our code will break. Okay, so these are filling in the places that we need to go next into the tree processing queue. This is taking the values and beginning the process of reversing them. So that's what we're doing here. So skip the loop if there are no children, and then reverse item if only one item, and then this is going to be reverse with two children, only one child position. There we go. Okay, great. So here, let's fill this out a little more fully. So if there's only a left side node, then we're gonna take that left side node, put it on the right, or excuse me, this should be if current dot right is null. Yeah. So if current dot right is null only, but current dot left is not null. Yeah, because this is when both of them are null. So this is when only the one on the left is, or right is null. Then we take the one from the left, put it onto the right, and then current node dot left. Let's see. So we could set stuff equal to null here. So that's what we're gonna do. Great, all right. And then we're gonna do this again, but for everywhere that there's a right, we're gonna turn it into left. So let's do that real quick. And I love a good Control D where you could select next so that you just do things a little faster or in one step. So this is the cases where it's one child. And then now we're gonna grab one of them and turn it into the case with two children. So, okay, let us do that like we said here. So this is left side, this is right side. So first, this is what we're gonna do. We're gonna put the left side into the temp. Then we're gonna do this, put the right side into the left side. Then we're gonna do this, which is put the temp into the right side. So we're gonna follow that counterclockwise circle. So we said we're gonna put the left node into the temp. So there's just gonna be the else block. Or, we don't have to put it inside of anything. It'll just be if the code gets to this point and didn't hit one of those if cases. Yeah, that is what it is. And then also needing to write continue here so that it kind of stops if it hits one of these places. Yeah, so while this is happening, we have to put any children node into the things that we have left to process, and then this is what we're actually processing, so all of these steps will have a continue at the end of them, except for this one, which is if you're at the end of the line here. Awesome. So okay, let's see. We don't need an if case, but we said we were going to start by putting the left value, saving that as temp. So let's do that. So current dot left, I'm going to save that as this variable temp. Oops. Okay, then what do we say we're doing next? So now we're going to be putting the right node into the left node. So let current, or no, we don't need a let because we're not defining something. We're taking something else and putting it here. Current dot right. And then now that current dot right is in the position of current dot left. Oh, sorry, I just realized this drawing is on the right side of the screen, so it might have been kind of overtaken by the chat there for a second. But yeah, here's the drawing. Sorry about that. Yeah, this is the tree that we started drawing earlier. This is the little rotation of where we're replacing the temp, right, and left values in a circle. This is when we were conceptualizing having a visited array and debating whether we were doing a stack or a queue, and looking at our three cases here, where the cases are that we could either have a node with no children, a node with one child, in which case we move the item to the node to the opposite side, and the same if it were here, just reversed. So apologies, and thank you for your patience if you were watching along with me. If you're just here for some body doubling, for some ambient noise of another person chatting, you're welcome to. Have a great night or day wherever you are. Anyway, so currently, where were we? We just set the right value into the left value. So now we're going to set temp into the right value. So we're going to say current dot right equals temp. All right, and then I think we did what we needed to do. We are returning root here. Yeah, I think the root would be in the same place. And we have the cases for the end where everything is null. And this is when it's empty. Yeah, we take out the value from the beginning. All right, let's see what happens. Okay, that's funny. Alrighty, so something's broken somewhere. Let's see what's going on. Ooh, a print level order. Am I doing that? What was input? Val. Yeah, as I've talked about in another video, I'm pretty sure they have like their code in the background somewhere where we can't see. That's okay. We'll figure it out. Sometimes it's helpful to like see the tests to better craft or curate the results, but that's fine. We can kind of infer a little bit. I suppose this is helpful, I guess, if you're practicing for whiteboarding, because sometimes they don't tell you, or they rarely tell you if you're on a real live whiteboard what the problem is. So, but I mean, I'm guessing that it's that we're not stuck in a loop, which is good. We're probably hitting a null somewhere, which is interesting. So let's add some console logs and see what's going on. Highly doubt we're getting here, or let's say end. Here, let's do the same thing and say while loop to just see that we're getting to here. And then I think it could be helpful if we also pass in the tree processing queue in our while loop here, just to make sure that we are where we expect to be. So let's see what we see. Ooh, interesting. Okay. So we're getting 0 console logs. So that means we're not even getting into the while loop. Okay. That's interesting as well. Okay. Well, something very interesting is going on here. So let's see. New tree is really nothing, so I'm just gonna take this out to make it a little clearer. If root equals this, return it. Let's just make sure that that works for now. Interesting. This is interesting because absolutely everything about this function is just commented out right now. I'm gonna try opening this in a new tab, see what's going on. See if there's anything we can do rather. Oh dear, okay, it actually saves your progress. Interesting, because I don't want to lose all this code. I'll store it in a copy for now. Okay, wait, I wonder if this is just saying that it's not getting the answer it's expecting. So console log root. Let's see it. Yeah, okay. Much more understandable, but weird that it wasn't working earlier for some reason. Okay. Well, definitely want to still do this. Okay, weird. But a win is a win, as we like to say here. Okay, so let's do some more of our console logs and make sure that we're getting what we're expecting to see still. So what am I doing? The pre-tree for, okay, and then right. Interesting. Wait a minute. So here I have tree node val 4. It's interesting. Also, I'm just like thinking about a better way to do this, which is just to put the root straight in here, honestly. Oh, I see. So we have this one node with a value and then left and right. Okay, great. Just what we're expecting. Cool. Okay, so then yeah, while this queue, let blah blah blah. And then what I want to do is just console log the queue at the end, and then return the root value. So that way we could try to narrow down what all's going on here, or where it's breaking, really. Okay, great. Oh, interesting. Just not pushing anything else into the array. Also, I'm not even sure I'm getting into here. Maybe I need to do the length, like make sure there's some amount of values. Wait, am I even console logging out here still? No, I don't think so. Oh, up here. Yeah, the root. Okay, let's see if we see anything from that while block now. Nope. So we are not even entering the while loop. Why? I don't think length needs a parentheses, but I'm just trying it for the sake of it. Or greater than 0? Like, what do you want from me? That's weird. Okay. Okay, this is a very nice, respectable while loop here. Hello, while loop. What is going on? So we start with while, and then a condition, then we have parentheses. While, a condition, you have the brackets, Also, this name is like ridiculously long. I'm just gonna change it to tree queue because it's easier to see and trace. Okay, so we have this tree queue that we make, and we put the root into it in an array. And then we say while and look at the length. Let's console log tree queue again, because I'm not sure what could be going on here. Honestly, I'm not even sure if the console log was working just now because I didn't see the words like pre-while loop. I just saw that console logging the root actually worked. So let's see what's going on. Yeah, interesting. Okay. I'm kind of thinking that like it doesn't like the root going into here. It might just like the root dot value or something, because it is saying that it's getting an undefined value thing. So let's try that. Nope. How interesting. Wow. But then console logging the root works only. Not anymore. This is interesting. Okay. So there's something going on with this if statement that's like, it's so weird though because we're not even returning an empty array, which is what I would expect otherwise. So let's do this. Let's be very specific here. Let's say if root dot value equals null, and then like see if we can actually progress in the code. Okay, great, fantastic. Fantastic, truly. All right, so yeah, at least now we're making it into the while loop. Great. And yeah, we probably have the left and right tree nodes, which is expected. Cool. So then let's now check out if we can get some of this code to run by uncommenting it out here. Just gonna go for the, long pass. Okay. We don't like the root dot left at some place. Okay, it's probably here, honestly, because I do remember last time it did not like setting two things equal to each other and null, or trying two things are equal to each other and null. Can't read properties of undefined. Like where? If I could only get a line, as if it were VS Code. Oh, my sweet, sweet VS Code. Well, I'm surely probably proving the point that people don't just wake up able to do this stuff. We all have to start somewhere, and with that, we're going to take another quick break. See you very soon. Back to the triers and to those who try and try again, while using an iterative approach to make sure we try again different and better whenever we try again. Yeah, they say one of the greatest ways to approach getting stuck on a problem is to take a break from it, so did that, check. And our audio is live. So let's transition back to the screen and take another stab at things. Or another go at things. Okay, so we are getting undefined somewhere in this loop. We are, I would have wished that we could define where we got up to. Let's try to put a console log in. Might still break. But we might be able, if it doesn't before running, or if it breaks while it does something, to tell where we get to. Okay, great. It ran twice. Great, okay. So that is telling me if we got through this, that... Okay, I'm guessing that we started with this first node, and then we got past here. It would have put, or it should have, let's say, or I imagine it would have. Ooh, actually, even better. If we're getting into here and we can see something, let's see what's in tree node, or tree queue. Because I'm wondering if it ended at the 2 or the 7, or somewhere else. Oh, I see. Okay, so it's putting in what? It's putting in the nodes? Yes. Interesting. I wonder if we can define something as? I think that is just in JavaScript, though, or TypeScript. Yeah. How romantically sad, how tragic. So let's see what we can do as an alternative, because that's really interesting. Just giving myself a moment to think here. Okay, so to think out loud for a sec here, and like reflect on the thoughts that way, I'm thinking like, should we create new tree nodes, or because like we can't, well then the other thing I'm thinking is like, since we can't like call that shape, we can't set a new tree node. Like we just have to use whatever we have and then like reverse it pretty much in place, which is, I mean, one way to do it, I guess. But we can't really like put something else together recursively. Oh god. Depth first search, yeah, okay. So essentially by not letting us be able to affect or create tree nodes, it's forcing us to use depth first search instead of letting us do a level order binary search. Okay, so I'm just going through hint 2 here. We can use the depth first search algorithm, and each node we swap its left and right children by swapping their pointers. This inverts the current node, but every node in the tree also needs to be inverted. So, oh yeah, this is helpful. This, in my opinion, could have been like a third separate hint, because often the problem with writing recursive code can be figuring out that initial base case or the toughest part, but okay, so I'm just gonna go ahead and comment everything I've done so far out, and then I'm going to take the end here and bring it up so that it's like never happened, but it did happen, and that's why I'm commenting it out just in case I need something later. Okay, nice deep breath to reset our thoughts, and let's try to write this again recursively this time. So if we're writing it recursively, I would want to go all the way to the end node first. Our base case, as they said, is if the current node is null, we return. If root equals null, return. That'll do it. And that should work for all of our deep cases as well. So then what we could do is similar to our case here. Instead of even worrying about like whether something has children or not, we could just do this case for all nodes. Because like this is our most expansive case, it'll work whether something is null or not. It'll just move the thing and continue on about its merry way. So let's actually, hey, let's use some of this code from earlier instead of calling instead of calling current node, we can call root. Oops. Okay, actually first let me comment this out, or uncomment this out. Let temp equal root dot left current, or root dot right, and then what we'll do is we have to call this function on the left value and on the right value. So then we do invert tree on root dot left, invert tree on root dot right. And when it's done and the root is null, it'll return the root. And so yeah, I think this should maybe get us a little closer. Okay, hey, you know, we're passing case 3 now. That is more than we were doing a minute ago, so awesome. Invert tree is not defined. That's interesting because it's defined right here. I think what we learned in the last problem though is that we need to call it with this. Similar to TypeScript files, but not exactly the same. Okay, now we can't read the value of what? Okay. Yeah, so for things like this here, I like to just do it if like the thing exists. I think that'll help. So if root dot whatever, and then I'll come fill this in, and like in this case it's root dot left. In this case it's root dot right. Excuse me. So that way we're not like stepping off into the deep end of a null situation. Okay, cannot read something. Okay, process input. I'm not really sure what that means. So let's see if we can get some insight into what's going on here with the console log print statement. Okay, so we start with the first one. We have these two values. Just gonna, I'm just gonna say like this is my little something I learned from a software developer a while ago, but it's funny because it was when I was in a different field, no less, but he would put like these flags of just like exclamation points of and like a lot of them so that it was really easy to see them in the printout. And I love doing that, like especially on something like this where there's just so much code to like look through on each section. That way you're like getting a clearer view of what's going on in each place, or like having a break line sort of in your console logs. Okay, great. Ooh, beautiful. Oh my gosh, yes. Great. Okay. Sorry, excuse my excitement there, but I am stoked that we are getting such clear view, like a clear view of what's going on. So we start with our first node, great. Then we end up looking at this node, then we end up looking at this node. Awesome. All right. Doesn't really have a right or left value. Awesome. So then tree node 2, 1 and 3, 1 and 3. Okay. Interesting. So this, I'm just gonna write some notes for myself to figure out what's going on where, and then we can come back to troubleshooting. So this is reversing left and right nodes. This is recursive function call on the children nodes. And then, so when we first get this tree in our console, their test case here. So this is the first node, this is the left node, this is the right node. So currently I am returning things exactly as they came in, with 2 being the left node and 7 being the right node. So first I want to see if the reversing of the left and right nodes is working, and to do that I'm going to run this again and expect to see 7 as the left node and 2 as the right node. So let's see if that happened. 7 is the left node, 2 is the right node. Great. Awesome. Left node is 9, right node is 6. Great. Again. Cool. Okay. 3 and 1, so that means we did get through everything on the stack as well. 3 being left and 1 being right. Okay. If root.left cannot read properties of undefined val. That's interesting too, because like I'm wondering if it's saying this, like, but then top, root, left, right, left, right, left, right. This isn't a tree that has like a singular value anywhere either. Oh, wait a minute. So, okay, no, this is if null is root. But then if root.left, add the left to the stack. If the right, add the right to the stack. Let me check that last case to make sure I'm doing it right. Cursively visit left and right children. If the current node is null, we simply return. Huh. Well, they say simply return. I'm curious about if this is what is needed instead of returning the root for some reason. Haha, no. Okay, great. That was swift feedback. Love it. Okay, so currently we know that an empty array works. What about a one-item array? Like, let's get into the nitty-gritty of where things break here. Do some good old test-driven development. I'm gonna go ahead and in here say if root is null, or if both the left and the right children are null. Okay, root dot left and root dot right are both null. here equal null. Awesome. Let's try that on for size. Okay, great. Okay, one step closer. Right, now I'm curious about if it actually does work in the case where we have like only a left or a right value, or if we need to have those auxiliary cases again. Yeah, how interesting. Because we are returning the root, so I'm really super curious about why this isn't working. Yeah, because we had to put it in as the left node, so it is doing this. I'm just like, return yourself. What is happening? Actually, wait a minute. So here we're returning the root. Wait, but it's breaking before it can do that. So let's trace this code through. We go in the first case where we go through this and we've returned this. However, dot left is null and root dot right has values. So we'll do this invert root dot right. And then here, I actually want to know if we re-enter this array, because I'm like hoping that, excuse me, your entry, that we re-enter the array after doing this, but I'm not sure that we do. Oops, oh wait, no, this is in the wrong place. I would like this to be up here. Because I want to just see if we called the function with the other value, because then we would see, you know, the cases, but okay, yeah, so we do call it at the end there. But then, I'm like, so you know, you being the function, that, let me just make sure I have no chat pointers. Okay, it's just me here. That's fine. We'll keep working. We'll try again until it works. So let's see what's going on. So we enter the function. The root is not null, and the children are not both null. Great. So we go through things. We reverse things like we expect we should. And we get to here. And then we console log the root. We call this on the left node. So then I wonder if it's this same thing from earlier where it was wondering if root was null or if root.value is null. I'm not sure, but it's worth a try. Ooh, funny. That would be a no siree Bob, because it broke the one that was working. Okay. Oh, wait a minute. That's interesting too. The fact that like the output is expecting root, null, and right. Let me try this with the other things that I had tried earlier of like the left and right null position things, you know? Because that is something that they're expecting the null in there too. So since these are cases that have ifs, we do them before the case that is both positions accounted for. And then currently, instead of current node, we're using the identifier root. Okay, let's try that. Funny. Illegal continue statement. That is a really funny diction or vocabulary. Okay, great. Something is going on with the return. Or, okay, that is my current thought. And maybe I'm biased with the fact that I think that something's going on with the return. But it's saying that it's not reading properties of undefined and it's trying to read the value of something. What value could it be trying to read that would be undefined? Like an object.value? Actually, let's see what it's taking in as root for all of these. Yeah, I mean, it should just be the left, right, and then flip right, left, but let's just confirm that. Yeah, so here we think we have value, tree node, null. Now afterwards we have value, null, tree node. Great. Okay, but I'm getting another tree node here. What is that about? Let's look at all our console logs for a sec. So, yeah, this is it. Top one, the exclamation point one. Oh, I see. Okay, so this is the root that we're looking at. So this is the first root we're looking at. Then here's pretty much where we finish, and this is our ending. And this is the first node that we're looking at. And root.left is null, and root.right is null. So we should be returning the root because we have a return statement. But we also have that we are not able to read the properties of val undefined. All right, let's get ourselves some other people's opinions. Oh, I see. So they're like, make sure your thing has a defined value before an if statement. So, wondering if I should test that these aren't null first, like how we did with the other code just now. I'm like wanting to paste it again, but that's funny. Yeah, let's just paste it from down here. The one child cases with the illegal continues. Illegal continues. Although, like, when we look at this code, it actually is already doing what it would need to do with this code, so that's not the issue, actually. Yeah, because it's already like returning or reversing the null in the tree nodes. It's that when we get to here and the left and right values are null, like it knows that root is not null, but it's not returning root. So let's try again with our test case of, oh, I see what's going on here. Yeah, okay. Let's try again with our test case of one item and see why this is treating it any differently. Okay, so here it understands that we have a value left and right are both null. And it can read it. What is happening here? Cannot read properties of undefined val. We pass in. Oh, I think this is kind of interesting. Oh wait, no, this is just that it's swapped the left and right. I was for a second there like, are we reevaluating the same thing? But I don't think we are. No, let's look at some other recursive code. Oops, hello. Recurse. I think getting close to a Stack overflow on the computer here, so I'm gonna give it like 2 more tries, 10 more minutes, whichever comes first. And if you're sticking around with the process of try again, thank you so much for being here. Just going ahead to show that, no one's born knowing how to do all this stuff. And, if this were an interview, we'd be long over time. So this is, I guess, why practice makes progress. And iterative practice makes progress go faster instead of just banging our heads against the wall. So let's try looking up some other recursive code examples. Just to see how they do stuff. So they have the function with recurse, they have the parentheses. Okay. If condition, stop calling yourself, aka return. Let's see. Like if number is bigger than 0, console log. Okay, it's not like returning anything. Awesome. All right. So if case, return a thing. So in our case, we are returning the thing, like the root. And then oh, right. I think I made the same mistake earlier. We have to return the other cases too. That'll do it. That'll do it. Yeah. Sometimes, we just need to learn lessons more than once, maybe more than twice, maybe several times. Oh, yes. Okay, great. So, yeah, how do we get back out of here to return the full something? Oh, by the way, here at Try Again Dev, I do have a playlist of like the actual solutions of the blind 75 in order plus a big O notation course in case anyone wants to like see how this gets done like efficiently. Thank you very much to AlgoJS. Yeah. Okay, well, we're one step forward to where we were. We are at least returning some things. We are currently returning. Yeah, so I think that this, as they said originally, would just be return if it's null with the overall root. And let's see what happens. Ooh, nada. A lot more nothing. Weird. Because what I'm like expecting is that it returns the 3, but I'm like, shouldn't that return it to the other function? Oh, wait, so I think that I'm doing this a little bit wrong here. So if there is a root.left, then root.left equals the inverted tree of root.left. So root.left equals this, And then I think that if there is a root.right, then .right equals this. The inverted tree of itself, like, yeah, okay. And then we can return the overall root, I think. Let's try that though. Haha, no, but you know, one step closer, so. Okay, still not outputting anything. We need a return statement with an equal sign. I don't think I've ever seen that before, but it's worth a shot, worth the old college try. Wonder if this needs parentheses here, or if it all needs parentheses, but I wouldn't know until I try. Try that. Still doesn't like the word return. Interesting. It's interesting that like now this error is also internal compile function. Like I'm not really sure what to make of that. I guess it was compiling earlier, it just wasn't very happy about it maybe. Like in this case. Where it's like cannot read properties, but it's like it does compile, I guess. Now I know that. Typo. I just want to know which line it's erroring at. We have if this is null, which is the val, which is what usually is the problem if this is happening. Root.left is null and root.right.null. Okay. So my personal and laptop batteries are both dying, so let's see what we're doing wrong here. So this looks like Python. Interesting. Okay, I didn't realize you could just save things as the other things like this, but sure. We have the this dot, we're calling it on the left, we're calling it on the right. Great, if not root, return null. Oh, interesting. So if root is null, I'm returning root, which is null. But, huh, that is what they're doing too. If not root, return null. Well, I guess we're all on the same page then. I'm doing it in the threefold way. They're doing it in the twofold array way. That's great. I didn't realize we could do that in this language. Oh, we have to return root at the end of this too. Okay, that does make sense as something I was wondering, but maybe my talking aloud meant that I didn't like hear my brain tell me that as well. So at the top of the function, we have the ability to return the root, but also we have to return the root after doing the operations on it. Hopefully I can remember that next time I encounter a recursive problem like this too. Return root. And then in the notes to myself, we must return the root at the beginning in case the function is broken and after all operations on the function. Okay, so this is pretty important for my notes. And also, yeah, sure, this can go into the tree section. To call a function again, we call it with this. To call a function again, remember to use this dot function. And then what other lessons learned do we have here? I'm not sure yet, but let's see if this runs now. Thank God. Or whichever deity you'd rather me thank. Put it in the chat. Okay, it looks like we have tried again with this problem. We've finally gotten it accepted after finding out that we needed to return root here at the end. Thank you for joining. If you join or watch on YouTube, Try Again Dev, where we try again until we solve things. Remember, work smarter, not harder. If something's not working, it's always okay to ask for help and learn more and ask why. Definitely you saw that process happening with me at different points of this video. I should have followed my own general 15-minute rule of like, if you can't figure it out in 15 minutes, go find additional resources, but always learning for next time. So thanks for joining.